like the first investor, I talked to him and he's just like, yeah, I'll put my money in. That's before the crash. That was like in August 2008, and nobody would put money in. I couldn't get anybody to invest. This meeting with the director of operations for this company for data center operations, and he described this whole thing to me, every 30 minutes or every hour or something like that, he's getting on a meeting with over 400 people. It went all the way up to the executive vice president. We had a customer really early on, and he's like, I don't think people want to have AI in their BMS. That's how he described it to me. Sort of fear just of AI. And then ChatGPT, especially when that came out, everybody got super familiar with AI, what it's good for, but they also got familiar with like hallucinations and things like this.
On today's podcast, we have Cliff Federspiel with Vigilent. Cliff, welcome to the podcast.
Thanks for having me, Eric.
All right. Well, before we get dig in here, let's learn about you in rapid fire mode. Yes, and get to know you. So, do you prefer late nights or early mornings?
I think probably mornings. Especially if I'm like out on my bike in the morning. It's really nice. Yeah.
Yeah. And then sweet or salty?
Definitely salty. Food can never be too salty for me.
Wow. Yeah. Introvert or extrovert?
I'd say introvert. Yeah. When I was a kid, I was a pretty shy kid. Yeah.
So what's your favorite food? And I bet it's salty.
Peanut butter.
Yeah. That
By
would
far.
probably be mine as well.
Yeah. Peanut butter is awesome. It goes with so many things. Yep. I use it as a training fuel when I'm cycling. It goes great on ice cream. There's all these great foods that have peanut sauce and stuff like Thai food. I mean, it's great.
Yeah. Anyways, favorite sport?
So these days it's endurance cycling. I do a lot of that, but I've done a bunch of other stuff. When I was in grad school, I played rugby and I did some masters water polo for a while. So, yeah. But
what was your first job before you got in the industry? So think like high school timeframe.
Yeah, I had this job in a high school where I'd go door to door selling, people like paint their house address number on the curb. So I sold the service of coming around later to paint their house number on the curb, door to door, one summer.
We had a guy come around this last summer to do that. You look like a high school guy.
Yeah.
I felt I did decline him, but then afterward I did notice that our number was really faded. So maybe I need to take up the next guy on that.
Yeah, that's right.
And then secret talent.
Yeah, I guess maybe this is something I kind of learned about myself from founding Vigilent is I'm pretty good at convincing people to believe.
I think that's a skill set that's important for founders, is to get people on board and believe in the mission, particularly when you're just starting out.
Yeah. Investors, new hires, customers, all of it. Yeah.
And then a few work questions here. Do you prefer meeting in person or email?
Meetings are way better. Just the email bandwidth is so low. It's only good for like little things.
And then air cooling or liquid cooling?
Liquid's the future. So that's what's driving all the interest these days.
And then who would play you in the Netflix series Data Center Wars?
I had to think about this one a bit. I put Daniel Craig.
Okay.
Yeah. I was thinking, like in Casino Royale, right? He just like never gave up. So first of all, he's gambling, he's taking risk, and then he just never gave up, right? And then more recently, I don't know if you saw, he's in the Knives Out series. He plays this character, Benoit Blanc, like an investigator. So.
Yeah, I like it. Okay. And so that for folks that aren't familiar with Vigilent, how would you describe, I guess, number one, what Vigilent does, but also how would you describe AI cooling or kind of, your technology to a non-engineer?
Basically, the software, it has a crystal ball built into it that allows it to look ahead, sort of predict the future and use that predictive ability to figure out the best thing to do now to create a good outcome later.
And the crystal ball is probably based on the data you collect and So
Yeah, and the
you're
machine
collecting
learning
data.
models that get built in the software. Yeah.
And so you're identifying trends. Perhaps every Tuesday it gets warmer in the morning, or whatever it might be. I'm just guessing because this is not my expertise. But yeah,
Yeah. What are the things that affect the things that matter? Some of that is based on the data model itself, like what's related to what in the software. And then what it does is it figures out of the things that the software is configured to do, how are those going to affect the things that it wants to, manage, control in the future.
It might be a little
Go ahead,
silly,
Mo.
but between the cooling and AI, what came first? The passion for cooling or the passion for computer science?
Actually, I learned about both kind of at the same time. I did both in grad school. I took a whole bunch of, so all my degrees are mechanical engineering, but I took a lot of courses over in, electrical engineering, computer science, brain and cognitive sciences. But the application that I was focused on was HVAC. So I've been doing the HVAC thing since grad school.
So was there a specific point or incident or something, a problem that you might have encountered that, provide a spark or an idea that you said, I need to form a company or build a solution?
So I left grad school, did corporate R&D for a while, and then took an academic position at UC Berkeley, worked on a bunch of projects having to do with wireless mesh networking, controls for buildings, and thought the time was right to, put all that together. So the technology, the wireless, the smart software, and apply it to building energy management. Because at that time, remember, clean tech was like all the rage, right? Investors were pouring a ton of money into that. So the whole energy thing was a really big deal. So we launched the company focused on applying the technology to old, inefficient buildings, like office type buildings, right? And it worked great. But there's two things. One, it was obvious that it was going to be a hard area to build a business. And then all the concerns about the rapid growth of data center energy consumption happened right then. It's like, oh, we should pivot to data centers. So we did.
About what year was that?
So we incorporated in 2008. And I remember in 2007, it's the guys at Lawrence Berkeley National Lab published a report on the, expected exponential growth of data center energy consumption. And that went everywhere and got a lot of attention. I think there was a lot of concern in the industry that, was going to result in regulation if something wasn't done about it.
Yes. I know that's been a concern for a long time. And it's primarily been self-regulated. Yeah, interesting. And those reports from the projections they had then are probably dwarfed by what's actually happening now and the expected energy usage that's gonna.
Well, yeah, it's exploding so much in the last 3 to 5 years that it's straining the grid in North America, right? Things like that. It's not about efficiency really; it's about capacity to deliver power to loads. That's really the problem now.
So you're president and CTO. That's two roles, right? And which curious of like what hat do you prefer wearing, and then how do you balance like kind of the kind of creating new products from a CTO perspective with kind of running the business day to day?
So we got a team that runs the business day to day. It's certainly not just me, and I convinced a guy named Mark Housley to join as CEO pretty early on. Which is a great move. He's great at running the business. But I'm interested in building really, like almost magical technology, but that solves an impactful problem, really, So you want to have stuff that's cool and exciting and really seems like magic. To some of our customers, I think, it does seem like magic, but that solves real problems that customers have. And so that's sort of the balance between the business. It's got to be driven by solving a real business problem.
I mean, at the crux is the problem that you're solving is kind of energy usage. So if you solve the cooling issue, is it about energy or is it really about cooling?
It was about energy when we started the company. We would sell and close, like everything about the sales process was about energy. And we learned along the way that that's hard because it's not the priority, really. So it's hard to, to have that as your sole value proposition. But we also learned that the value of the solution goes way beyond energy. But the other, just to extend on that a little bit more. So you mentioned energy saving. So the same actions that the AI produces to save energy, they also, help the equipment run longer, more reliably. So you get better capital efficiency, you get fewer repairs and all that stuff too, along with it. It's the same thing. It just basically is turning things off that don't need to be on and slowing motors down and all of that, which, and that, some of that value is, more, quite a bit more valuable than the energy. And then finally, if you're not using up a bunch of energy for cooling, that means you have that power available for the IT. So, if you have the ability, and we have some customers that actually done this, they, shuffle their assets around so that they can basically get more capacity out of their data centers.
That's all that we're dealing with all the time is finding more power, and there's concern that there's not enough power in the grid, et cetera, right? And do you find that, because it almost surprised me at first when you said that maybe your customers maybe aren't, or prospects may not be as in tune with a dollar saved is a dollar earned, right? Meaning if you're saving money, that's not compelling enough, but perhaps maybe finding more power in that data center. If it's a 50 megawatt data center and you can be 5%, I don't know what your efficiency ratio is when you deploy, but if you can save 5% on that's significant. It's several megawatts.
No, it is. It's real money, but it's not the only thing, and it's not the number one thing on their list. There are a bunch of other things, so the other ones that I mentioned, like labor, we have a partner in Japan, and this is what they've told us right now is like labor is their number one problem. The Japanese are aging out and they're not bringing in a lot of immigrants, so it's just getting really, really hard to find good employees in Japan. So being able to make the people that you have more effective is super valuable.
Right. And so do the systems go beyond just, obviously beyond just cooling infrastructure? It's almost like, is it a replacement for a DCIM or?
I think it's, sort of works alongside DCIM. I mean, a lot of what DCIM does is asset management. So keeping track of things, and especially like, some of them keep track of things as they move in and out of the data center. So, that's not what a Vigilent system does, but there's certainly overlap. And the thing we've done in the last, 4 or 5 years is extend so when we started the company, it was sort of a point application for optimizing cooling in data centers, right? But to make that work, we had to build all the platform infrastructure underneath it. And so we finally got to the point where we said, we need to just turn this into a platform. And so we've now extended our data model so we can natively model all the assets, so the power assets or even the IT assets in the data center. Those can all be represented in the software, which means then you can, assign data to them, have trend data and all that kind of good stuff.
Do you have some good examples? My dog just knocked over my garbage can below my desk. Anyways, do you have any good examples of maybe building custom apps for a customer? That sounds interesting to me.
So we've built some apps that allow our customers, so in our software, we have a temperature map, and we have another thing called an influence map. So I mentioned the crystal ball, that's driven by a thing we call an influence model. And so we can visualize that so people can kind of see the effect of cooling on different parts of the data center. But, we had a customer that wanted to do more visualization than that. They wanted to be able to see like temperatures in their data center, asset by asset, but also back in time. And so we created this thing that the engineering team named it Neo. It sort of looks like that, that pattern in the Matrix, Yeah. But then when you look at this thing, like in a single snapshot, you can see exactly like where temperatures are getting too high or too low over time and which ones, and they sort of cluster together. So it's this analytic that the customer wanted to be able to have so they could not only see what's going on right now, but look back in time and have it all in a single graphic.
It sounds like that would be, even as an app you built for that customer and it was custom for them. It sounds like you could almost take that and then roll that out to the rest of the.
Well, yeah, that's the idea, right?
Yeah.
Is, and this is, like, I think an important kind of like part of our business philosophy is to solve customer problems, right? So build the tech and the apps for customer problems. And then, like you said, chances are pretty good if one customer has the problem, another customer has the problem.
Let's see. So from a tech perspective and talking about the sensors, I'm kind of curious of like how these are placed throughout the facility. Do you put one in each rack, or is it one in each row, or how are they placed, and what else do you measure besides temperature?
Yeah. Well, so a lot of the time we provide wireless telemetry to our customers, and like our nominal default is top and bottom, or high and low on every third rack. Okay. You can go lower density than that. If all you cared about was just saving energy, you can go lower density than that. But then, like all the visualization in the UI starts looking a little wonky because it's hard to get the interpolation to work right. So all the analytics and the graphics and stuff like that are really, a bunch of those are quite a bit more valuable if you increase the sensor density.
And AI, you talk about using AI in the system, but AI is a term that's used very broadly, and AI can be many different things. Machine learning, large language models, physical robotic models, that sort of thing. So I'm kind of curious in the context of Vigilent or data centers, what do you guys use for AI under the hood? Is it an LLM that monitors this, or is it some sort of other?
We don't, and This is the thing, as AI and the public's understanding of AI has sort of evolved as the technology is rolled out, kind of unaware of it in the early days and maybe a little bit afraid of it. Like I said, we had a customer really early on, and he's like, I don't think people want to have AI in their BMS. That's how he described it to me. Sort of fear, right, of AI. Now people are like, and then ChatGPT, especially when that came out, everybody got super, familiar with AI, what it's good for, but they also got familiar with like hallucinations and things like this. And so when we go to a customer sometimes and they hear AI, they're thinking, oh my God, you're going to put ChatGPT in my cooling system. I don't want that. And it's going to hallucinate and that thing has, is, out at a third party cloud and, all that stuff. So it's not an LLM. We don't put LLMs in there. We have, like I said, we have a thing called an influence model, and we use machine learning to train the parameters of that. The models are like, I don't know, millions of times smaller than, like GPT-5. So the software trains these machine learning models automatically, doesn't require any human intervention, and then it uses those models to optimize. So it makes optimal control decisions using those models. Yeah, it starts off with sort of a template model and some simple control to make the things safe. And so the software does sort of two kinds of control actions. In the reinforcement learning area, there's this term explore versus exploit. So some of the time to facilitate learning, you want to explore, you want to have the software explore so it can generate information.
Can your model hallucinate? And if so, how do you prevent from it doing so?
It can. And when it does, like what happens is you'll see, so I mentioned we have temperature maps, right? And we also have influence maps. And if it does hallucinate, what you'll see is the influence maps look kind of ridiculous. Like it'll tell you that if you, change the state of a cooling unit, that it'll get, 40 degrees hotter or some, or even, something that's just obviously wrong. And so what we've done is we've designed the machine learning algorithm so that it makes it quite a bit more difficult for the machine learning to hallucinate.
So how exactly does it learn the cooling behavior? Can you walk us through kind of what happens from when you install your sensors to the point where the system starts generating recommendations?
Yeah, so we configure everything. We'll put in the sensors, connect the software to whatever thing it's going to send a signal to do control. Sometimes that itself is a wireless device that's on that wireless network we were talking about. So we can do control over the air. But sometimes it's across a network that's already there, some OT network, it could be using BACnet or Modbus or SNMP, something like that. And that could be either directly to the asset itself, or it could be routed through their BMS. Some customers like that because then they can write some code in their BMS that basically allows them to control conditions when they want to, either allow or disable Vigilent control through their BMS. So it gives them sort of an automated way to have control of their Vigilent system outside their Vigilent system.
And then how do you leverage your full deployment across different customers to kind of build these ML models, or is it all, does all the learning happen at an individual site? Or maybe a combination of both?
Most of it is site-based, right? Because the design is different from site to site. So I mentioned one of the ways we deal with the hallucinations is we have a prior. So the prior is based on kind of an average of what we've seen over, a lot of installations that we've done after the model's been trained. But, there are a lot of differences from data center to data center that need to get factored in. So the majority of the information that ultimately affects what the influence model knows about the site is based on the data from that site itself.
But certainly if there's a certain manufacturer, a crack manufacturer in a certain model, right, you might learn something across multiple customers, and then you could apply that even in a new installation, knowing that crack unit or the expected behavior of that crack unit.
Yeah, you could. Although, the design of of air conditioners is kind of has a sort of de facto standard to it. And the other thing that we see is that, even though you might have like a whole lineup of chillers, right, that are nominally identical, and they were just commissioned 3 months ago, and when you start looking at their behavior, they differ by a material amount. Yeah.
Unique things when you put them in, into different environments.
It's just like a fleet of cars or anything else, right? They look the same, right? But when you actually like really carefully measure their behavior, they're not the same. They don't all. Your fleet of cars, every single one of them isn't going to get exactly the same gas mileage, and it's going to change over time. Yeah, what's why put AI in a data center and have it optimize the cooling, right? And the reason is all the value that it delivers, and the value is a lot more than just energy efficiency. It's making the people who run the data center more effective because they don't have to do the low level stuff anymore. The software takes care of that. It's the improvement in reliability and capital efficiencies because the equipment lasts longer, doesn't have as many failures. And it's the ability, these days, like we were talking about, it's the ability to have the AI help the data center not use so much power for cooling so that it can use more for IT.
Mm-hmm. Makes sense. And I've been meaning to make a slide in one of our customer decks that talks about the rack densities and how they're increasing. I think it would just be really cool to show it. Say for example, 10 years ago the average was maybe 4 kilowatts a rack, or maybe even that's being generous. And then not too long ago it was 10, right? And then some of the AI systems with the H100s were 30 or 40 kilowatts a cabinet. And so GPUs are pushing that, right? The current deployment at NVIDIA is like 130, and with a roadmap to in the 200s and 700s and a gigawatt perhaps.
The announcement just this week, right? Of Vera Rubin is now gonna like double that.
Yeah, which is insane. In terms of this density that as data center operators, we're expected to be able to support this rapid growth in power densities. So I'm curious of maybe what you're seeing from that perspective. Maybe how Vigilent is working through those densities, or any thoughts in terms of.
Well, so we've had customers. Customers are certainly worried about it. Like our colo customers are coming to us and asking for help because it's a daunting thing for them, right? They're going to have to build this really expensive asset, a data center, and they want to still be having this thing, useful and generating revenue for them years into the future. And yet, the rate of change of the IT assets and the power it consumes and the heat that it generates is, escalating exponentially. So they're trying to figure out what to do about that. They're trying to design them so that they're as future-proof as possible, right? So that they can, connect the next generation of liquid cooling to their cooling plant and still, be able to put those high-density racks in. Yeah, it's a challenge for the designers for sure. Yeah.
So I guess what would be the potential solutions that they're looking at? And I know you're a little bit outside that realm, but can you speak to that piece?
Well, they're trying to design so that the design is flexible, right? So that they can connect in new liquid cooling assets in the future. I think like some of them fully expect that they're going to have, they're going to start off with large rooms that are pretty full and end up with large rooms that are not very full because the density is so high and they only have so much capacity.
Yeah, I think I only watched a couple episodes of, what is it called? Severance. I think is it HBO or Apple, where it seems like it's weird because I never really got the show, but I know it's very popular and it's maybe.
Yeah, I watched the whole thing. Yeah, it was.
Oh, did you? So,
yeah.
Was it good?
Yeah.
Did it turn out to be better? Yeah. Okay.
Yeah, I liked it. Yeah.
They have these just 4 desks in the middle of a large room. So it's almost like that's going to be our co-location environment in the future. It's like you have like 4 racks in the middle, right?
Yeah.
Which is bizarre. So how does Vigilent work in a liquid cooling environment? It's easy for me to visualize, okay, in an air cooled environment where you measure, outlet, or the inlet from cold air coming into the server.
So to a Vigilent system, a CDU looks an awful lot like a crawl unit, right? It's another thing that the cooling plant, the chiller plant, is serving. It's got a chilled water valve where the chillers are delivering water to it. So our software optimizes the air cooling in the data halls, and then we have software that optimizes the set points for the chiller plant. And if you have CDUs, then it's going to do the same thing in order to produce the best outcome in terms of power efficiency for the whole plant.
Yeah, that makes sense then. You can integrate into that. No problem.
Right. Yeah, and integrating is easy. I mean, the controls that are on CDUs, it's all the same commercial and industrial controls that you can integrate with protocols and of various sorts. So getting data from them is not an issue. So,
Cliff, can you describe how a customer might deploy? And I'm sure there might be a couple different ways you can deploy. For example, do you have to have sensors or not? Do you send everything up to the cloud, or is it all there on the customer's prem or within the customer's environment?
Right. So the software, of course, needs sensor data, but where that comes from, it just sort of depends. A lot of the time Vigilent provides sensors to our customers, but more and more so, these data centers are all fully instrumented before, if it's an existing data center or even one that's new, a greenfield, they're going to design it with sensors all in the places where Vigilent software needs sensor data. So it's becoming more and more common that a Vigilent deployment is only software. Now, where that software resides is nominally on-prem. We find that our customers don't want to have a third-party or public cloud connection to their infrastructure.
And then maybe moving on to more personal things. So we want to ask a couple personal questions and then maybe get into a data center war story and your top picks. So what is the best advice you've received? If you can think of, I'm sure there's lots of advice, but is there any?
Yeah, when I was a grad student, there was this famous beloved professor who his advice to the students was tell everyone you know everything you know. And you can't really do that in business because you got things that you can't say, right? But to the extent that you can, I think that's great advice. Because, we were talking about believability and convincing people to believe. And so being able to tell them in detail about things that are important to them, really helps. It gives you credibility.
Does that mean like it being more transparent? Is that what is that the concept there? Is being transparent and open, and maybe, I don't want to say oversharing, but transparently showing?
Well, I think so. So this professor, I think what he was trying to counter is the sort of the academic tendency to like keep everything like safe and secret until you can publish it and like release it to the world, right? And you see that in startups, right? They go into stealth mode and they don't want to tell anybody anything. But getting people to believe that you have something means that you got to tell them. And so you got to talk to people. Yeah, you got to be somewhat transparent. Otherwise, they don't believe.
And this might be related to the data center war story. So if so, we can move into that. But what is the toughest moment of your career, and how did you get through it?
Yeah, so one really tough moment was really early on. We incorporated in 2008, and I started raising money, from
2008. That was the financial crisis.
Yes, it was.
Yeah, the Great Recession. Okay. That you started. So you and Elon Musk, he raised money in 2008 for Tesla. I don't know. In other words, it's a tremendously hard time to do business, particularly as a startup. So go ahead. I just,
it was super hard, right? So the first investor, I talked to him and he's just like, yeah, I'll put my money in. That's before the crash. That was like in August 2008. And the crash happened, in September, October? I forget which now. And nobody would put money in. I couldn't get anybody to invest.
But you still had that first investor's money.
Yeah, the first investor, maybe I had two at that point. Yeah. Mm-hmm. Put a little bit of money in. So, right. This is not VC. This is like, angel investors putting money in the early days.
So from that, you had enough, and you just had to scrimp a little bit more than you would have. You didn't have
it got really hard. No. It was, right. There wasn't 500 people that I had to, make payroll for. So it was, that part of it was easier, but it was hard. It was really hard. I mentioned that I convinced Mark to come on board early. That was part of that, right? Nobody's going to invest in me. I'd never made anybody a gazillion dollars before, but Mark had a lot of business experience. And so he added to the credibility of the team. So basically, one of the things I did was like strengthen the team so we could, get through that. And one of the things I did, in fact, to help win that grant is that Steve Chu, who was then the Secretary of Energy, he was given a talk over at the Harvard Club in San Francisco. So I went over there with a 2-page printed out thing about Vigilent in my business card, all stapled together, sat in this room, had dinner, and then Steve Chu shows up, and all of a sudden the crowd just immediately crowds around him. So I wormed my way into the crowd, got up there, was able to talk to him for 30 seconds about what we were doing, handed him the 2-pager and the business card. And what I heard later through my contacts at LB&L is that he reviewed every single one of those proposals. And so maybe that helped. I don't know.
It might have, right? I mean, I think that's a way to kind of get ahead in career is not just sending in a resume. You send in a resume in a unique way, or you show up in the door, or you reach out to them over LinkedIn, right? It's about really interjecting yourself and putting yourself out there, because otherwise you're not known. If you're just an application without that personal introduction and putting that name with the face, and he's like, oh, he's eager, he seems smart, he wrote something that was good and it resonated with me. Who knows what it is, right? That actually got you that. But
the other thing that happened when I was talking to Steve Chu is I explained to him what we do, and he started telling me how the system ought to work. And so I told him, no, you're wrong. And here's why.
Was he, in retrospect, was he wrong? And you're right.
Yeah. No, he was wrong. Yeah.
But, I mean, he's probably smart enough to kind of see your perspective on that then.
No, he kind of paused for a minute, thought about it. He's like, yeah, okay.
Yeah. Okay, cool. Yeah. That's always risky to kind of call someone out. You don't know how they're going to react.
No, you don't. But, seems like maybe it worked.
It worked. Yeah. So let's move on to the data center war story, although that sounds like the war story right there. But Tell us about a time, either yourself or protect the innocent if it's a customer, that sort of thing. But what is there an outage that happened or something that and how did you recover?
Yeah, there was a couple of them. So I'll give you two, and you can decide which one you want to go with. But
maybe both. So yeah.
So tech company got our system installed, getting ready to turn it on, and they had a BMS vendor, guy that would help them run their BMS from the BMS company, and he just did not want to have this Vigilent thing turned on in this data center that he, I think, felt responsible for, helping this company operate. And so he was like pushing back really hard about turning it on, and he escalated this all the way up to the director of operations for this tech company. And I thought it was just going to blow the whole deal up, and this is early days Vigilent. And so we really needed this to happen. So I got on a call with the director of operations and the guy from the BMS company and just like went through every objection that the guy had, and, it said, this is what'll happen if that happened, just all of that, and got the director of operations to agree to let us turn it on. So, we had and we always do. We had somebody from Vigilent there, carefully monitor it. I assured him that, we'll have a person there. If anything happens, we'll just roll it back. It'll be good and safe. And of course it was a great outcome. And the interesting thing here, and, credit to the guy from the BMS company, he sent us a note afterwards and he said, I would have never believed this if I hadn't seen it with my own two eyes. It was amazing.
For sure. Yeah. And what was the second one?
So the other one is we have a customer. It's one of the gigantic financial companies. And so, they're super conservative and kind of similar sort of attitude amongst some of the people in the organization. They're not really comfortable with having a Vigilent system in there operating because, something goes wrong in one of these data centers. It's a real disaster, right? They run trading floors and all this kind of stuff. It's just terrible if something goes wrong. Now we designed the Vigilent alarming system, so it's got has these roll-up alarms, so you don't have anywhere near the level of granularity. Like you can alarm on every single little thing in your BMS, and I think because of that, people often will. And so what happens is if you have an event like that, that's what can happen. You get this alarm flood, and it's sort of like a denial of service attack on your BMS. And that's what they had. So the only thing, and so I had this meeting with the director of operations for this company for data center operations, and he described this whole thing to me, and he said, I forget how often it was, every 30 minutes or every hour or something like that, he's getting on a meeting with over 400 people. It went all the way up to the executive vice president. Explaining what's going on. He said the only eyes that he had was his Vigilent system. So after that, they love Vigilent.
Yeah, I bet. Yeah. And you just filter out, you just didn't take on every alert. You filtered
Yeah,
them
that's
out.
right. The software, mostly, our kind of thinking is, first of all, look, you got a BMS, so it's got a bunch of alarms. You got an EPMS, it's got a bunch of alarms. Maybe you got DSIM, it's got a bunch of alarms. So we're kind of frugal in what we alarm on. We do have, and we've actually recently, built in more flexibility to, do alarming. But, and this is kind of a thing that, a lot of our customer facing people are almost, sometimes complaining about, oh, we need more flexibility in our alarms. And so we have added that. But when this happened, we didn't have that yet. And frankly, it was a good thing. Mm-hmm. You alarm on the things you need to alarm on and no more, because here's an example of what can happen if you don't.
Yeah, it makes sense. Let's move on to the top picks section. So this is a time where we have a guest provide and I can provide a top pick as well. And no one is your choice too. But effectively, you anything in your life that you find useful that people may or may not know about, and you can go first, or I'm happy to go first. Your choice.
Well, I was looking at your list, and so the travel tip. My travel tip I would give people. Well, there's sort of two of them, but the very specific one is if you're traveling in London, hold on to your phone. I was traveling with Mark in London and we were heading to a meeting and he's holding his phone out in front of him like this. We're navigating while walking to a destination and motorcycle. So I'm on Mark's right-hand side and the streets to our right, motorcycle pulls up right alongside me. Right. And so I just kind of like move over closer to Mark just naturally. It's like, what's going on here? The guy uses that to lean in, snatches his phone, guns it, and heads off. And then he stops about 100 yards ahead, turns, looks back at us and waves, and then rides off.
Is that like a little like creative flair that the little wave as he left? I mean, like,
but this is in London, they have a major problem with phone theft. Yeah, it's really bad. So you gotta hold on to your phone if you're traveling in London.
I thought, I don't know. I've been in the Apple ecosystem for a while now, and so I don't know about Androids, but I thought like it's becoming. I thought it was becoming harder to steal because I have heard that there's this problem in Europe where people come and snatch phones. But for me, it's like, can't you just lock up the phone and put it in lost mode?
Oh yeah, he did all that, but it was like a lost half day the next day. Like dealing with the fact that he didn't have a phone.
Yeah. But I feel like, if I leave my phone out on the table at a restaurant or whatever it might be, right, I feel like safer than having my wallet on the counter of something. Like if the wallet can't be tracked or it can't be shut down or off or whatever or disabled. But
but if you're traveling, you lose your phone. It's a problem.
SOL. Yeah, no doubt. Yeah, at least for a day until you get to a store, a mobile phone store. Yeah. So don't keep your phone. You kind of
don't wave that thing around.
Yeah.
So I have for travel, it's not like a fanny pack, but it's much thinner and it's to be worn kind of under your shirt. And that's where I keep all my travel documents.
Yeah, that's a good idea. Right.
It's like super thin. Passport, a little bit of cash, and then my phone is the only thing that fits in there.
And for me, I would say I had held off on buying a Tesla for the longest time. And I bought one in mid this year. And it was partly because outside all the politics that seems crazy that it's gotten to that point. But outside of that, like I don't pay attention to politics much. But for me, it was about the technology. And it getting closer, right? And so I followed it, read about it for a while, and it felt like full self-driving had gotten to the point that it would be worthwhile, right? To and so got it and had been using it, and it's been, I don't know if you have had an experience like this or a Tesla yourself.
Well, so I live across the bay from San Francisco, so I've been in Waymos. And those things are awesome. It's amazing. Yeah. That technology is just great. I love it.
But Waymo is like, it's great, but it's something that you have to procure. And I'm in Denver and that's not available here. This, I can have my own garage and pull out, I can just program in where I want to go, hit a button, and it drives me there and now parks. And I barely have to, correct it at all. That sort of thing has gotten to that point. And I, my wife she's okay with it, but she doesn't use it that often when she drives the car. But for me, in my mindset, I'm like, I have a dishwasher to wash dishes, right? So I don't have to sit there and wash the dishes. Same thing with a washing machine and all that. Machines are meant to offload our, just like you talked about with Vigilent, right? You have a machine to do work for you and replace labor and all that stuff. I don't need to I still pay attention to the road, but I don't have to, it takes a cognitive load off and relaxes you a little bit when you're driving or riding along and having the car drive. So
yeah, we have a Subaru. Amazing. It's got this thing called eyesight, with the lane following and car following. And it gives you some of that, right? You get in stop and go traffic, especially if it's on the freeway. You just turn that thing on and all you have to do is point the car. You don't have to really do anything else. It's much better. But I may have to look into because this self-driving stuff is great. I mentioned I do a lot of cycling, right? So I'm, interacting with cars all the time, and it's not fun. Let me tell you, sometimes interacting with cars. But I was over in San Francisco. I'm coming along the Embarcadero in the bike lane, and it's a really narrow bike lane that they provisioned for the cyclists on the Embarcadero. And there's a slow cyclist in front of me. So I go to pass and I kind of move over a little bit, but I don't want to go all the way out into the lane. And I kind of can see in my peripheral vision a car is there, right? And it pauses. And that's sort of unusual. Like cars don't give cyclists that kind of room usually, right? Especially in San Francisco. So I look back and it's a Waymo. So it saw me move over a little bit. And, the law is you're supposed to give 3 feet of clearance if you're going more than 25 miles an hour. So it did. And it waited for me to move back into the middle of the lane, and then it carried on. And, so the safety benefit of self-driving, and in fact, I use this as an example when I'm talking to people, trying to get them to believe about AI. There's like really well-documented evidence about the safety of driverless cars compared to human-driven cars. It's like 5-1 safe.
Oh yeah. Yeah, for sure. There's no doubt. Yeah. I would bet if you look at it, and you probably know better than I, but safety on roads for either pedestrians or cyclists must have been declining for even now, because I think that there's a lot of distracted driving with phones.
Yeah, phones,
people are
right.
on their phones and that sort of thing, and distracted, updating whatever they're updating on their phone or reading. And with self-driving, it becomes safer, just for the example that you gave with cyclists, right?
Yeah.
So I think 10 years out, I think the roads are going to be a lot safer.
Yeah.
Yeah.
I can't wait.
Yeah. All right. Well, thanks for jumping on. Learned a lot about this. This is a topic I didn't know a lot about ahead of time, and we got pretty technical, but where can we find out more about you or reach out to you if anyone has questions or want to reach out to you?
Yeah, so I'm on LinkedIn, and Federspiel is a pretty easy Googleable name, so I'm pretty easy to find. But certainly find me on LinkedIn. For anybody that cares about cycling, you can also find me on Strava, and I let anybody connect who wants to. So
cool. They can see your routes and speed and such. That's cool. Awesome. All right. Well, thank you, Cliff.
Yep. Thank you, Eric.